Alright, let's go. Only 2 hours tonight, because I fucked up, but how it is. Okie doke. So, dynamic memory allocation, so far we know main strat is to save it, save the memory we want, and maybe initialize it like a pointer to an int, and we'll call it x, or I'm gonna say xp to say that the pointer. I mean, sure. I don't know. I'm just gonna do that. It feels better, and I'm gonna give it a dynamically allocated integer. I'm gonna initialize that integer with 7. A dynamically allocated piece of memory holds value 7, address of which is stored in XP. This new int turns a pointer to that int. And then later on, when I don't need it, I can delete XP, and then XP is assigned null pointer to stop XP from dangling. No dangle-thon, yo. Right. Alright, how far? Pointers. Memory allocation. The point here is there are two pieces. One is, well, yeah, I guess there are two separate things. There's an int pointer XP that's initialized with a new piece of memory here, dynamically allocated to value 7. And I can check if XP hold null pointer, aka is it valid? How is that? Oh, control slash comments the line. Okay. Oh, that's nice. Instead of having to go here in space. Oh, it's so much better. Kidding me? Oh shit. Yeah, it's way better. I don't really like this, so I'm gonna keep doing that. Fuck it. I don't like this, it not having a space there. It fucks up readability for me. And we can check this, and then, oh hey. I mean, really, there's two things. So when we have pointers, we want to check to make sure they're valid before we use them. So if I wanted to print them, or if I, let's see, not even if I wanted to print them, let's say I just want to increment it. I want to increment XP. That's some cool operator stuff going on there. We're incrementing the value that XP is holding, so this sets XP to 8. More concisely say, increment XP, XP's are increment XP points to 8. Okay. Problem here is if we delete XP, still evaluate to true, because deleting it does not assign null pointer to it. It assigns some other address to it. It doesn't hold the same address. We've checked that. Print it here. You print the address XP holds. It's whatever. 80 blah blah blah. When we do it here, you get a bunch of zeros after you delete it. But it's not 0 all the way down. Nope. It is somewhere else. So I wouldn't be able to evaluate it as a condition in this case to see that it's valid to use it. I have to make sure that I'm assigning XP null pointer. See here, what is the error? Using uninitialized memory, meaning that we have taken the piece of memory, taken XP, and deleted it, so we have freed up that memory. Now, I guess point is that I guess that's what it is, right? It's saying it seems like there are two pieces whenever you deallocate memory. So if we have this block of memory here, and let's say this is our stack, and we have our code. All right, we'll say we have our code here. Fuck it, we'll just say here's our code. Okay, and I have XP here. Then we have this massive heap. A little piece of memory in here. I want a piece of memory. Let's say I get this piece. 0x, whatever. This is our little piece of memory. And XP points to this guy. Then I can assign value of 7, be there. And but when I delete this guy, right? So when I delete him, what happens is this piece of memory is now shut off. It's now no longer accessible here, which means it used to be pointing here, but now it makes him point to somewhere else. Like null, I'll just say is here. This. I think it's just a value. It's not actually a memory address, or maybe it actually is the first piece of memory, the first thing that exists. I don't know. But if I assigned him to be null pointer and I printed XP, it would print 0x000, add infinity, right, forever. But if we delete this guy, then it makes him point to something almost 0, not quite null pointer, but similar. 0x000, like I get 1823 or something like that a lot. Which means when I evaluate him, when I evaluate XP, we do not get false. We actually get true, which is not what we want. So we want to make sure that after we delete him, we also have to assign him to be null pointer. Steps are XP gets some new guy, some new int, and then XP is some type pointer to that type, right? Pointer to this type, pointer to this type. Then say this, use this value, say okay, we can point to here, we can assign values to it, do all this stuff, use it, blah blah blah, stuff. Then eventually when we want to free it up, break this tie, we have to delete. And we also have to XP null pointer, right? And point him down here, this null value. Because otherwise, we can't evaluate XP. It will falsely evaluate to true. In reality, pointing to knows. So we have to initialize a null pointer to make sure that it's like 0, false. Okay, so we have to say here XP null pointer. That way we can now evaluate them as a condition. Boom. Say in this case, oh, null pointer is not valid, we're not getting it. Else their output that is not valid. Can't increment the value it's pointing to. Start. Somewhere random. So it's helpful to say, like, and the other thing we could is we could do in code, or we could do, we'll do here. Say a pointer to an int called XP. and we assign it to be null, or we could just leave it blank. It's the same thing, but sure, null pointer. And then later on, we could check if not XP, then we want XP, the value to copy it, because we have to assign it by copy assignment. Can't initialize it because it's already initialized. Say new int assign the value of 7. Then and we could also delete XP, and because it started with null pointer, we're either deleting it if it started with null pointer, or if hypothetically it wasn't null pointer, we're deleting we're deallocating a pointer to actual allocated memory, and deleting a pointer that is pointing to null pointer doesn't do anything. Deleting a pointer that is pointing to allocated memory, then allocated memory specifically instead of automatically, statically, something like that. Free it. But if we do this, we also need to XP is null pointer, just in case. Or we could check, we could say if XP is not, or sorry, XP, or if XP is valid still, then XP is null pointer. I don't think this is intensive though, so I mean, could just do XP is null pointer. So even though this is redundant in this case, hey, it's null pointer, it's not when actually, but yeah. So this is going to happen. It's not valid. It's holding null pointer, so it's going to evaluate to false in this condition. Then we're deallocating it, but it's not going to do anything because it's still, actually, no, it will, because it's now holding dynamically allocated memory that has the value of 8. And then we're assigning a null pointer. But in this case, what if we said it's valid? In this case, it's not going to do this. Right? So I can undo that with Control U. Deleting it won't do anything here. Assigning it null pointer won't change. So you could have if XP is, you could say if XP, then we do this. That way we're only doing this if it's not freed. But yeah, I mean, I guess that makes sense, right? Because it's find a value to see what it's holding. One is do identify the parts where you want it to go null. Do okay, delete it and make it null. And you can delete it evaluating true. Well, actually, no, because if it's evaluating here, it might already have been deleted. Because if we delete XP here, we deleted and assigned a memory address of something like that, something like this, very low. Then we're deleting it again. It's already uninitialized again. So don't actually want to do this. We really just want to say if not, that'll work. Say if not XP, but we're still evaluating something. It seems like it's still okay. We're just checking to see if it's that. The point is, if it's uninitialized and we're evaluating it as true, it's interesting. And what if we do the same thing here and we do XP, XP? Oh, okay. So the issue was still there. It was just okay. Never mind. All right, ignore this. So you wouldn't want to check it. Really. So we can check. This is the important part. We're using the condition. Check if it's so if it's holding null pointer, then we know that it's holding null pointer, right? No allocated memory. It's not, and that lets us allocate. Hard part is making sure that we're not memory that has already been deleted. And I think the way of doing that is if you make it so that every time you ever delete, you just assign it to be null pointer. Say, oh, delete XP. XP null pointer straight away. It almost seems like it makes sense to do, I don't know, this is possible. I don't think it's. I can have. Maybe I could put it in parentheses. Well, let's see. Define test as delete XP. And I just say test. Fuck. No? Oh, this is like some crazy syntax, I think. It's gonna work. I don't think it will. Wait, maybe it did? Alright, let me get IOStream going. Well, I guess I kind of want this. So, setting it as no pointer. It's not initialized with this. Then I'm going to test. And I'm going to make it do. Oh, shit. Test. Oh, maybe it's the whole line? So what happens if it's this? Is the we can't just run these in global scope, right? Yeah, because it doesn't know what XP is. When you say test, it's replacing this with this syntax. What happens if we this? Still fine. I could define it and then I could stream. Then it's oh. Okay. Some crazy things happen. Don't do it. Maybe because test already exists. I'm not sure. Okay, don't do that. When does the macro actually works there? That is surprising. We do just a test. Oh shit. That's how Unreal Engine works. Nothing. Argument. Oh, a function like macro. Whoa. Does it need? Oh shit, it works. Oh, interesting. A lot of crazy macro stuff. Okay. Context of dynamic. It says no memory has been allocated here, so the point is we can evaluate it to see it's not. The problem is if it hasn't, it's been deleted. Whenever you delete memory, assign it no pointer. Just do it. Because otherwise, whenever you evaluate it, it makes it unsafe. You don't know if you're evaluating it to be. You don't know if you're evaluating memory that is already. You don't want to evaluate memory that's a condition. Every time you do it, you have to add in assign no. It's non. mean that it's still read. So stack pointer, keep pointers pointing to the memory in the dynamic allocated. It's nothing. This guy. Okay. Then this guy's destroyed. Up. Right? Yes, if we have clear data memory, and delete the pointer, memory has and destruction of this particular object has not automatically. Is this a smart pointer? Yeah, we need a class. Yeah. Yes. Yes. We don't know what type. We could do make it a class template. Yeah. And we'll say so we have a default constructor. The main thing we want tilt. Of this, nothing. Could say called. Okay, so that's fine. Or we use this. Called chill. What we're doing is on destruction. Well, the problem is if we delete it first, I'd almost want another function to save whether, well, like one thought was that this would be a pointer that we don't have to free memory for. We just, I mean, one thing would be if it's assigned memory that's allocated. Well, we could do operator overloading too, I think. Maybe, if the assignment operator is able to do it. Basically, I'm thinking this. A smart pointer, by definition, could be a pointer that when it's assigned value, let's say when it's created, it's given whenever it is assigned value, it is deleted first. It is deleted and then assigned. Say that. I almost want to say that. It's deleted, assigned null pointer, and then assigned value. So we are first deleting it to make sure we're deallocating it, and we're adding a null pointer. So just in case you had an extra logic, you don't have to worry about just assigning value to something that hasn't already been safely initialized. Excuse me, I was going to say here that you could do, this is what I was thinking. So you'd create the pointer, give it an address, and then whenever it gets destroyed, you don't have, well, oh, could say, this is what, not default. Pointer is assigned T. This is M. Okay. Have to initialize the address. Something. Then we make it const. Well, fuck. Make it const. God damn. Can't exactly that. Oh wait. Hold. Wait, we could, right? Yeah. So make it a const pointer. So it can't get any other addresses. And okay. And then free memory. Problem is we can't. Oh, this is actually fine. We don't need to assign it null pointer because we're just deleting. Free memory when before destroy before destroyed. Okay. The point of this pointer, the smart pointer, is that we create it and it requires it must get address. And maybe it has. What if I said it's a new one? Nah, I guess not. Is it here? Or what if we said, oh, I guess I can't really initialize it then. There's no identifier for me to put if I just put new and then a pointer to a type, like we normally do, new or new t. Oh, what if we said new t? Maybe it wouldn't work? I guess not. No, duh. Well, I was just trying to, it wasn't giving me errors, so I was surprised for a second. So the point is we give it an address, it cannot be reseeded to anywhere else. And don't free it. And whenever it's destroyed, it's the only thing, and yeah, and we can't even assign it to be, the only thing is so we would want to make sure that we can't do it somehow. So we could create test smart pointer called x, and it gets a new int that gets 7, that has the value 7. Okay? And I could print it. If x called it's oh, I guess we have to get the value, right? Oh. Here's the thing. I guess it doesn't matter. Need the pointer, right? So the point is we create smart pointer, or rather initialize smart pointer. I don't think it's actually smart, but smarter, I don't know, probably not. And then we want to actually check it's valid, and so in this case, works, and the memory is freed, so we don't have to do delete x get pointer. Is that even, I guess, right? Or hold. Well, it's returning it, so we'd have to, I can't get it by reference, can I? It's not, right? Well, hold. No. Oh, no, we can't. Okay, I was just not waiting. I didn't wait long enough. Okay, it works. Cool. And then I don't have to say x get. I don't have to say, oh, x get pointer. Oh, hold. I'm just getting. I'm getting a pointer. Isn't this just getting a temporary pointer? I'm not actually getting this one's. I'll get a reference to a pointer. Oh. I mean, I guess we could just make it public. We could just make. Oh no, but well, I guess so, right? I guess you would want this, right? All right. So we're checking to make sure the pointer is valid, printing the value, and then we could delete. But then this would be deleting it, deleting something that's already deleted. So if we delete, we have to say x m pointer null pointer. And then we're deleting and no issue. Wait, hold on. Wait. Oh, what's a const? So we can't reassign it. So we basically can't delete it. You'd have to have some way of not being able to delete it. The point is, so we can do it here, but it doesn't work because it's a pointer const. It's just kind of yuck. But I don't know. The idea is there. Problem is we can't delete it deleted. Okay. If the operating system will do it. Yep. So we're creating a pointer, we're allocating memory, and then we're destroying the pointer. Memory's still free, it can't be deleted. We don't have a way of accessing it to free it. So the point is, while the program is running, it's occupying this much memory. But the point is, in the program's life cycle, there are probably cases where some of the memory is not executed properly. Some of this memory doesn't need to be ran. It's using this much, but it only needs to use this much because lost the addresses this memory, so you can no longer free it. It is stuck occupied. But when your program finishes, then the operating system can clean up everything that your program was previously using. Reclaim other ways. A pointer holding. Oh yeah, it doesn't have to be just destroyed. It could also be assigned something free. So if you have a pointer holding a dynamic address, you need to make sure that you freeing it before you're assigning it something else, unless something else gets that address. So value is 5. We give this pointer this new place in memory, but then I had assigned it the address of 5. Well, now that new place in memory's address is gone. Yep. To delete it first and then assign it. Meaning that an allocated place allocates. So a pointer to, can you have that? I guess maybe pointer to a pointer, but the second pointer that's being pointed to is allocated memory. So a pointer to memory or a pointer that holds memory elsewhere. Free that place of memory, and we have to free this place of memory. New in. Oh, double allocation, meaning that the pointer is initialized holding some new place in memory, but then it's assigned to be holding a place in memory. So now the previous place, we don't have an address of it. It's just somewhere out there. It's lost at sea. The bottle's out there, but it's lost at sea. I don't know where it is. But now I have a new bottle. It's in the sea. I have 2 bottles out at sea. Out at sea. They don't need to be. Maybe. It overwrites. Yeah, it overwrites the address. Okay, I thought it said something different. Delete it before you send. Yep. Variables. Careful not to dereference a dangling or null pointer. Or dereference dangling or null pointers. We could remove and A here. Raise. Oh, the fuck? Interesting. This is short. I feel like it's gonna say don't do this too much. Maybe? No? I guess not. Really? Yep. Normally the array size needs to be known at compile time. Choose the length at runtime. Because it's at runtime where we're allocating the memory. So we can't even do it at compile time, so it wouldn't make sense to make that restriction. C style is the most common, okay. Need an array of a specific size that's not known at compile time. New brace, delete or new brackets, delete brackets. See standard definition for what? Size T? Oh, I guess so. IOStream has it, but sure. Transitive, so we don't really need it. From there, we may as well include what we need. Meaning that we can actually put an object in the braces. So the point is, in the braces goes size. Oh, so now I could dynamically get an array of a specific size from the user. We could do that in different ways. So, well, the point is dynamically here instead of automatically with the standard array that's not dynamically allocated. So in this case, we could do IOStream because we need to get input. Please. Say we could say, oh shit though. What is it going to be a pointer to? A pointer to an int still? Oh. Yeah, because how does this even work? I'd have to get the pointer to a specific one. Oh yeah, because address of, yeah. I mean, we may as well just get address of x0, right? So if we get the size, surprised that works. No go. Yet. Works for some reason. Not freeing it. Okay. I could do that too. For loop work here. I don't think. See, it's not the right type. Yeah. All right, so less than the size. I think that should be for each, right? And we have to extract to it, right? I only want to do this if XP is valid. Dereference XP. Get the array. And fix it with I. Hold. Is not happy. Hold on. It's an array of integers. So I should be able to dereference XP. Get the array, right? Even then, still no, huh? Oh, the point is we can subscript it anyways. We don't need to dereference it like that. We can just subscript a pointer to get... Oh, interesting. Okay. Then we can do for const auto reference element in. Let's see. Oh, wait. No, still can't. because it's still just a dynamic guy that we're holding in a pointer. So it's the same thing, I think. For I is less than size. XP. Are we sure though? Isn't this maybe? I guess it gets the value, doesn't it? So I'm gonna say 2 integers. I'm gonna do 1, 2. It's gonna print 1 and 2. I'm gonna print 10. 1, 2, 3, 4, 5, 6, 5, 4, 3, 2. Oh, okay. Kinda cool. But then at the end we have to delete XP, and XP is null pointer. Say 3. Okay. I don't like this too much, but I need to get comfortable. See, this is the interesting part. We have to subscript it. Pointer to fuck that. I don't know where you went. From outside because I don't have any gnats inside. At this point, it must be. It's just cap. Okay. Subscript. Okay. Subscript it to assign value to the array, specifically setting 0th. Oh shit! To deallocate the whole array, we can't be. Oh, I forgot. New is different. So new requires this guy, right? Around the size. But then, oh, true, because we did this and it wasn't working. It's allocated with, but it's delete, scalar delete. Now it works. Mm. Well, sure, in this function. Okay. Don't even put 0 here, bro. We know you have to do null pointer because it's the explicit. It's the explicit pointer value. New is called even though I gotcha. So the new works whenever it sees the brackets placed around the size of the array next to it because it needs a size. Unless okay. The problem is the size, though. Excuse me. If we create it like that. Yeah. Of dynamically. Okay, not just regular C style. Okay. Even though it is a C style. If I make the size negative for a regular C style. Makes sense. Isn't there a zero size one though? Never mind. Oh, not for const expression arrays. It could be a standard vector, but that's it. I think. Mm, hmm. 100 mil. That is a lot of numbers. Um, fuck. What if we even hit a mil? I have no concept of scale for that. That's wow. Probably a couple mil, I'm guessing. array version. Making it multiple instead of one. Surprised it doesn't do type deduction. Hey, you're an array. Delete them all instead of, oh, hey, you're not. Delete just that. Great. Undefined behavior, data corruption, memory leaks, crashes, everything else. Undefined behavior. Good. Oh, interesting. Thanks, New. Yep. 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 Pointer first of the array. That's a dynamic array, huh? And we don't even know where that location is, maybe? Oh, meaning dynamic array is the pointer to the first element in that array that's been created. Exception that the programmer has to dynamically deallocate. Yep. Well, yeah, if we're going to do that. Oh, good. I mean, that's what I did earlier. I was using initializer lists. In there? Cool. That's what I was doing. Oh, because before you'd have to set it to 0, right? Oh, fixed array, sure. Oh, instead of saying a pointer to an int, new int, or auto new int. But now I have to look not only at the type of here. Oh, what's the type of this guy? Auto. Oh, it's actually an int. Instead of just saying, oh, int pointer. Okay. Yeah, who the fuck's using the damn assignment operator? Hello? What is that? Copy assignment? Uniform meaning not specialized, not. Yeah, we already know this. Yeah, uniform meaning we're not putting the size here. It's reduced. Dynamically allocating an array allows you to call resizing. No built-in way to resize an array that's already been allocated. Size is the size. Dynamically allocate a new array and then copy this. don't resize standard arrays. Just use, or wait, what? Okay. Don't resize dynamically allocated arrays. Use them for C-style arrays that are not resizing, that are not getting resized. It's like I wouldn't, oh, I want to resize a C-style array? Bro, I'm just going to create a standard vector. I know I need to resize. Doing a dynamic or a dynamic size array versus a fixed size array, like that. Program asks the user how many names. Create a string array. Initialize nothing. Loop through. User names. Sort. Print. Okay, we don't. What if we do something like I think we need to see standard def. Yeah, let's do it. What do we want it? What do we want to do here? Huh? Create the guy first, sure. We'll get the number first, I guess, right? Pointer to a standard string. Names. And initialize them. Okay. Okay. We want, say, inline so it can be defined elsewhere. Does it take? It takes a standard string pointer, right? Well, what's the and the size, right? And name count. Say 4. Standard size T. sure I, while I is less than the size, increment I, and hold. Why not? Oh, what the fuck? What am I doing here? Oops, I should have just looked at which file it was giving the error in. Okay, and we can sort them. Do this, and then we'll do standard sort, and I can pass it. Can I pass it that? Really? Is that possible? I don't know. Let's test this real quick. Oh, I guess it should probably prompt the user, right? Okay. Mm. That's not gonna work. Hello? Yeah, what is he talking about? We're gonna sort. Seems like I'm gonna have to do a regular loop like selection sort or something, huh? Or hold. I mean, I guess I could just pass the pointers to it and then plus size, right? So we could pass in standard sort, and then we could call the function too. Or maybe it's already doing least to greatest, so I think it makes sense as default. So we could do sort, all right, names 0 is the begin, and then names 0 plus name count, right? Hold. Oh, wait, hold. It gives the value, isn't that the problem? Hold. Oh, why? Hold. Complaining about. Oh, hold on. To names plus -1? No, even still. I think. Oh, wait, no, because this will be the end. This is one pass. Okay. And then what if we do full function action? Do fuck. What is it? Does it return true? Oh, I don't remember. We'll compare names, and it takes 2 standard strings, right? We do them by reference? I'll do my value just to test. So we'll do A, standard string B, and then return A is greater than B. Or return A is less than B. Or no, A is greater than B is when we swap, I think, right? The fucker, dude. What's wrong with you? What's happening? What am I fucking up with? That's the first, and that's the last. Oh, it's the fucking address, bro. Address. Let me read these errors critically. Does not, hold on. So it's in algorithm. The problem is inside algorithm. Something is happening with source. Binary minus. Ran it. Nobody knows what that means. It's not defined this operator. So the minus, I guess. Or conversion to a type acceptable to it. So, oh, it ran it. Iterator. It iterator. I'm mentioning overload found, so it can't take these. What is this? I looked at this and I saw, oh, it's a standard string. Oh shit, it's a standard string. Alright, so we actually need the address of this guy and the address of this guy. So we can print it, or we can test it. We'll do 3 names, E, B, G. Then we can print names. Okay. Do void print names. Print names. It takes a standard string pointed to a standard string called names and a standard size t size. And don't we have to loop through like that? And excuse me, for standard size t, excuse me, I, and it's initialized with size, while I is less than size. Or hold, what am I doing? What's less than size? Increment I to go to the next element, and we'll output. Just output names I, right? And so we'll do print names, count, or name count, right? 3, Ethan, Jason, Jack. Boom. Now we're gonna do 5, Zach, Q, fucking Zerch, and Bip. And it should go Bip, Ethan, Q, Zach, Zerch. Bip, Q, Zach, Zerch. Nice. So the result should be how many names? A number. Names. Pop. Your sorted list. Oh, sure we could do that. Oh, oops. This should be AHXE. AHXE. Cool. What, another one before? Okay, fine. Okay. Standard get line, sure, if you wanted. Yeah, standard get line and standard character input, passing it to standard white space to then ignore the leading white spaces. Or rather, I guess, to just include the white spaces, but also to ignore the leading white. No, standard get line gets the whole line, including spaces, but we're passing standard character input to standard white space to, I guess, compare the current shit that's in the input buffer. Oh, maybe standard character input is somehow evaluating to standard character input dot p. The next character is a space. It is a standard white space. Then cuts it out and then extracts. Interesante a mí. And yeah, point is says to be a pointer to an array. Cannot do it the other way. Oh, I need to get the address of the subscripted. Oh my god. That's so stupid. Right here. This, bro. So bad. Names. And, oh my goodness. Names plus name count. Would have thought that would. Not thinking. Okay. Subscripting and then reverse the subscript. Yeah, interesting. Yeah. That was stupid. Constructors. Huh? We're gonna use them properly to free a memory? Here's the point. Pop. Shit. Oh, it's not even long. It's just a lot of shit in the end. Not even a quiz. Ooh, rye. We learned rye. Nice. See, net resource allocation is initialization. That means something. Is the point that it's saying that resource allocation, meaning that if I've allocated stuff from the heap, that is initializing stuff. That is using up memory. You have to operate. Using up memory is using up memory, right? Seems straightforward, but maybe not. Like, maybe. Yep, I know this already. An object goes out of scope normally, or the dynamically allocated object is deleted. It's a class. The constructor gets called. Trying to do a villager. Dynamically allocated object is explicitly deleted. Using delete keyword. If the object there is a class, the destructor of it, its destructor is called, then the memory can be freed up. Just doing a cleanup before it gets removed from memory. Oh, but if the class includes things that are dynamically allocated, then it needs to delete those. The point is that we shouldn't delete them early on, because otherwise, if the destructor is undefined behavior, because you're somehow you're accessing the memory that's already been deallocated. Rather, you're accessing this unknown place that your pointer gets set to when it's deallocated. When whatever it's pointing to is deallocated. It means you're looking at that pointer and evaluating its memory again. You don't know where that is, so maybe you don't want to delete that. And if that place isn't allocated, you allocate unallocated shit, stack memory, happens. I don't know. Oh, I bet you my mic's fucked up. I bet you it is. Oh, I told you, I knew it. Woo. Bet you haven't heard a word the whole thing. GG's. Okay. That makes sense. Let's do an example. What's an example? Um. Oh. Well, hold. I was thinking about, no, that wouldn't work. If we had I was initially thinking if we had a monster and the monster had a data member that pointed towards a character, and then the orc got destroyed, we'd want to delete that. But no, bro, that's just a pointer to the character. That's not a pointer to anything dynamically allocated. We're not dynamically allocating shit for the character. But if you had dynamically allocated shit, oh, there's paint in my fucking mouse, really? Unreal. See if I can smell the paint. What would we be dynamically allocating? Stuff that is created only for that object. So for example, what I'm thinking, like if there was a class called missile, you could do it two ways. You could do, well, nah, this makes the most sense. I was gonna say you could have a class called jet, and then you have dynamically allocated missiles, so that when the jet's destroyed, you clean up the missiles. But if the jet got blown up, the missiles are still going. So you don't want to just delete the missiles. But if you had a missile, and the missile got destroyed, by definition, the whatever extra little bits of the missile. I was picturing a missile that shoots other pieces of itself or something. And if the missile's destroyed, then those must have also impacted, but maybe not. I'm trying to think of an actual really good example. Using destructors to clean up. Dynamically allocated memory. So what is a class that has data members that are pointers to dynamically allocated objects? When something gets destroyed, what else do I 100% want to destroy with it? That are dynamically allocated and not persistent things. Maybe footprints. So, I mean, it still doesn't work because they should be persistent in the world. But maybe that's what you do. Maybe you have a game that's like Bannerlord, and people are in this muddy battle, and when the character eventually not dies, but when the character is composted or whatever, or burned, then his footsteps go away. Okay. So I'll do that. We'll do like we'll do a character, Or we'll do a soldier class. And he has dynamically allocated footsteps. Because you don't know how many footsteps, and they're going to be saved forever. If he takes 100,000 footsteps, he has 100,000 footsteps. Which means we're going to have an array of footsteps. And each it should actually be an array of objects that are footsteps, and each footstep should hold, a 3-element standard vector with its location, right? Can I do that really quick? Fuck, this might be interesting. So we'll say soldier is a class, and it has, I'll just say a pointer to an int array. Sure. It has, well, how do we, maybe this is fine. We'll say it's an int pointer called m footsteps. And it's initialized with a new oh, fuck, we need the size though. Well, maybe we give it an int that it can take. Give it an int pointer that it can take, I guess. I think we just do it in the constructor. We don't set it here. That way we can take any size. Maybe? Because it's a pointer to an int, a pointer to an int. And maybe it has none by default. So we could say private for now, public, soldier, takes an int pointer called footsteps, m footsteps is assigned footsteps. And then we loop through and then delete it. I wonder if the array delete is funky and isn't able to delete static guys. I don't think so. We'll find out. All right, and then we could have, oh, I want this to be explicit too. Fuck, but we need the size though. The size of footsteps. Maybe we need the size. Yeah, fuck it. We'll do that. Sure. Well, no, it can't be const. Hold. Fuck, the footsteps change over time. Fuck, footsteps needs to be resized. Yeah, whatever, it's fine. It's fine, it works in this case. Oh wait. The fuck am I looping through it for? Bro. Right? I'm not tripping, right? It's as easy as it gets. I didn't have to do anything, really. Alright, oops. I almost kind of like a little ending bit. Oh, I'll make it say, actually this could be more. And whatever. 1,000 footsteps. Alright, hold. I have it. Fuck. Less than that, damn it. Who's on the mic? Bro. Why are gnats so touchy? What could he be eating on me? Oh, awesome. Okay. Oh, wait. Bro, why is it a fucking array of footsteps? It should just be a number. No, because we're saying each one of these would have a separate position. So sure, I'm gonna pretend like they have a separate position. So we'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or fucking 10, sure. And then, and this is a standard string view. Okay. Boom. I exist. And then we could say, and the size of the footsteps can't change. It's fine. Oh, great. Oh, because footsteps. Oh, true. Forgot that it's a pointer to it. Oh, wait, hold. Oh, if I wanted the size, I guess I would have to get the whole size of the thing, huh? And sure, we could do the multiply by the size and divide it. So, oh, it's 40 divided by 4 for int, 10 steps. That's correct. Turn my AC to 0 so I can go to sleep. Okay. I could loop through, but that's so shit. I could do this. I could pass it. Oh. Yeah, sure. Fine. Fuck it. I'll do it. Well, hold. Oh, the size of an int type. I don't know how to get the type, but whatever. We know it's an int in this case, so we'll just say, this is bad math, but it's fine. Gets us the answer, right? Size of m footsteps. Oh, fuck. Hold on. Fuck, we can't get the size because it's already, it's a pointer to it. It's not an array that we can look at, right? It's only going to point to one int. It's pointing to the first element. GG. Yeah, fuck it. It's fine. It's fine. Point-is been created, exists, and it's saying deleting Ethan's footsteps, and we're deleting the footsteps. Cool. Okay. Yep. Man, these fucking... This has to be older. Oh, it is. That makes sense. I was gonna say, because in the recent chapters, like how recent were destructors? Like, where are classes at? 12? 13? What's temp 14? Oops. Destructors? Am I dum-dum? Hello? Oh, it's actually, oh shit, okay. Yeah, say more recent. Because we already went over those, but now we're going over them in terms of dynamic memory allocation, how they're actually used, instead of just showing, oh hey, this is, I mean, they can do shit. Because this is when they're actually needed, not just to print a fucking death message or something. Because like usually, if the object goes out of scope, the thing that makes it, or well, if it just goes out of scope, okay. But if we're explicitly ending it, then we could just manually print. Or we could print inside the destructor. But now here we actually have to do shit for sure. Yep. Well, because if you called it, it would do that behavior and it would clean it up. I guess it would do whatever's in there, and then it also calls when it's destroyed. Yeah, the destructor is more like the pre-destructor. Like the, hey, last chance before he's destroyed, what do you want to do? Do you want to leave the region yet? Destructor example, okay. So we've created an array of integers. Pointer, hold. Pointer to an int, and we do store the length. Okay, so in our case, we would just store how many footsteps, and then print the footsteps. Okay, so we would do that. And then in our constructor, We take the length. How are we getting length? Hold. Oh. Hmm? Oh. Because. So what, I'm dereferencing him to, or oh, I guess I'm subscripting him to assign him values? What the fuck is this? Why are we using this? It's a C-style array. Oh, the point is that's the syntax. I forget direct when you you specify it like that. Wait, isn't that same syntax though as standard vector or standard array? I don't remember. Am I good? Oh, it's just my sock. I was wondering what was going on. So creating it, put explicit, and then length. And then we're assigning him array to be this dynamic guy. Makes sense why you're doing it in the constructor. Because length isn't known up here. Oh, yeah. So you're creating int array with 10. And that's calling the constructor with 10. 10 is greater than 0, true. We're not killing the program. And then we're initializing this pointer to an int with an integer or a dynamically allocated array of integers. The length of size t. So we're converting length to a size t. Could have just made length size t, but okay. And it's also only used in that case, so it's fine. Instead of returning it as a size t, which would be annoying. Excuse me, and then setting the length to be the length. I'd rather do that before, but okay. And then when we're destroying it, delete him. Set the value, get the length. Okay. I'm gonna brush my teeth and go to bed. I meant to do more, but ran out of time.